All right, we're on.
Oh, it's a long quiz.
Yeah.
Yep.
Oh man, these like first 8 questions are the ones that kill me.
Yeah, I
Yeah,
don't get
all
it
the word.
either.
I put that link in the chat.
Awesome, thanks, man. I'll look that up.
So, let's see.
All right, so I needed to like request access to that, so I just sent that request, Lauren.
Oh, okay. That's weird, but okay.
Yeah.
So the first one is chi-squared, g-squared test of independence, right? Possibly.
Hold on, what? Oh, keeps
I think
going.
so.
Yeah, I
I
think
don't know
so.
if there's that many
You have the
selections.
4 different boxes or whatever.
Yeah, that's what I would say.
And I shared it with you. You can use
Okay.
it now.
Okay, awesome. Cool, got it.
Sweet.
Thanks, man.
Yep. This one's a test of two proportions, I think.
Yeah, I was trying to decide if it was two proportions or if it was paired, but I think it's two.
Why do you think it's two proportions?
Because, well, what was confusing me is like if you know who's in one group, it doesn't mean that you automatically know who's in the next. Like you have to know the age
Yeah.
to know.
Okay.
But I don't know. Maybe if you did know the age of one group, then you know that anybody with a different age would be in the other. But I still think it's test of two proportions.
This is number 2, right?
For 3. Sorry.
Three.
Oh, sorry. For question 2, it's the chi-squared.
Chi-squared, yeah.
Oh.
Is that how you pronounce it?
Yeah, chi.
Okay.
Sorry, so what do we have for 1? That's what I was...
1, I actively participated in this lessons group meeting.
Oh, shoot.
Did you start the test?
Oh, no.
Oh, no.
um,
Oh,
maybe
man.
you can just close out of the page and I'll let you continue later on.
It won't. Once you start it, it's 4 hours.
Is it? Even if you just close it or turn off your internet or something like that?
I think that's how it works, but I would,
Yeah, I'm just going to exit out and I'll...
yeah, and email him, and he'll reset it, I'm sure.
Double check and see, because it might say continue test, and if it does, then you should be fine.
No,
but-
all there is save all responses and then submit quiz. So I was wondering why you guys' was so different than mine.
Yeah, that'll do it. Man, that sucks. I hate that.
Yeah. Dang it.
Well, good luck on it, bro. Are you gonna take it or no?
No, not right now.
Test of one proportion?
So I'm trying to remember when it's like one proportion and when it's like a z-test or a t-test. I think so. The z-test is when you know the standard deviation. So we know it's not that. So is it one proportion or a one sample t-test? Well, I guess you're determining the proportion, right? So
Yep.
okay.
Do you think I should submit the test?
I would just close out of it. Just close your tab or your browser.
I did that, but I was just thinking. Okay.
And if it'll let you continue it, then that's great. If not, you'll have to.
Yeah, I'll just email him.
I don't see why he wouldn't open it up for you.
Yeah, I'm sure he will.
So we're on 4, right?
Yes.
Yeah, 4 we thought was test of one proportion.
Yeah, I think so.
Oh. What would this one be?
I'm trying to think of it if it's paired sample because it's the student.
That's what I was thinking.
Like it's the same student with the different locks, so I think it's paired.
Okay.
Yeah. I think that's tough.
This be independent samples T confidence interval?
Yeah, I think
Or
so.
I was thinking it was paired sample.
paired?
Well, because it wouldn't be. It's not dependent on. One of them's not dependent on the other one.
Right. They're trying to.
They're trying to see the two different like averages of theirs.
I'm gonna open up the spreadsheet because I think a lot of times the spreadsheet helps to like look at which ones it would be good for to see like how many different things. So if they're evaluating 6 different properties, like what is it that you can actually do that with?
Because it says that they're evaluating it, so it's going to take the 2 guys, and then it's going to take, and then the bank is going to do it. So wouldn't that be 3? So wouldn't it have to be independent?
I don't know.
No, it's the same 2 appraisers.
But the
Yeah,
bank, they're
Oh, the
comparing it
bank,
against the
no.
bank, though, right?
All right, so let's see. I mean, this could be an ANOVA test. I don't even know if that's like one of the options.
I don't think so. This one's worded kind of funky.
It is. So how many different people were doing the appraising? 2 appraisers.
Yeah. They just did 6 different properties.
Yeah.
But then the bank is also they're gonna compare it against the bank too.
No, the bank just looks at the properties that the 2 appraisers appraised.
And make sure that they're the same.
Well,
So looking at the spreadsheets, I would say it's a paired sample t-test because that compares the differences.
Yeah, because the bank doesn't evaluate properties on its own. It's always just the 2 appraisers. That's what I was saying. Is it's worded kind of funny.
Oh shoot.
Yeah, so I think it's C.
We had paired sample t-test for question 5 too, right?
Yeah.
Yeah.
Yep.
Is this confidence interval for 2 proportions?
So in that spreadsheet, that's where you have just like x1, n1, x2, and n2 that you put in. So we would need like I don't think that would be right. I don't know. So I don't know what the x1 and the x and the n1 would be. Usually that's like the n1 is the sample and the x is the number out of the sample that had something.
Okay.
I don't know. These things get me all the time. Oh, because so you're not measuring it against anything else. You're just taking a sample of 55 double stuffed Oreos to measure the amount of filling in each one.
Oh.
And so we need to construct a confidence interval to estimate the true mean filling of double stuffed Oreos.
7?
Huh?
Did you skip question 7?
Oh, I totally did.
Yeah, that's the one I was talking about.
Then I don't even know.
So is this one the confidence interval for two proportions of 7?
Yeah, I think
That's
so. And
what I
that's
was
that's what
thinking.
you said, Lauren, right?
Yeah.
Sorry, I skipped ahead. And I do think that is it, because this you would take the proportion of people interviewed and who said satisfied in one major and who said satisfied in another or whatever. So yeah. For 8, though, that
It's one sample T-confidence? The Oreo? Or what it...
that's what I'm trying to figure out right now.
There's 42 problems.
Yeah.
Oh, man.
I think it's a one sample t-test or t confidence interval.
Okay.
I'm down.
I'm expecting to get all these wrong.
Hopefully not.
I gotta leave a little early tonight, so I'll tell you if they're wrong or not.
Okay. So, question 9 is the probability of type 1 error.
And 10 is C, right?
Yep.
Yep.
You said B.
C for
C.
10.
Oh. Sorry, I'm trying to email him right now.
It's all good, man.
You should just shared some screenshots with us.
Yeah, no kidding.
Nah, well, let's see. Is D, maybe?
It's not D because there is
No.
no chance involved because you've already
Oh, yeah,
done
that's
the
right.
thing. I think it's B, and
It's
the
not-
only reason I think it's B is because I think I got this wrong, or one like this wrong, and I remembered that being the answer.
It's B?
I think so.
So it's not D.
It's not D
No.
because in this case, the test has already been done, so there is no chance involved whatsoever. It's like with they explain the flipping the coin. Before you flip the coin, there's a 50% chance. After you flip the coin, it's either 0 or 1 because you've already
Makes
flipped.
sense.
Yeah.
Okay. It's 30 for 12. No, it's not.
Isn't it 0.3?
I think it might be.
Hold on. I'm gonna look in the book real quick and just make sure. See if we're missing anything. It's 0.3.
Okay.
If you look in the lesson 16 recap, it says the sampling distribution of p hat has a mean of p and a standard deviation of whatever. And then you look down below, and it's like the value minus the mean, so p hat minus p. So I think p is the mean, so it'd be 0.3.
All right.
Cool. All right. So I emailed him, but
Cool.
I don't have 7, 9, or 11.
7 is confidence interval for two proportions.
Okay.
9
And
is
8 was one sample t confidence interval.
yes, and 9 was the probability of type 1 error.
Okay.
10 was the probability of observing a sample statistic, more extreme.
Okay.
11 was 95% of all 95% confidence intervals actually contain the true mean.
Sweet. Thank you.
And you got 12 and 13, right?
Yeah.
Cool.
Well, no, not 13, just 12.
Oh, we were on 13.
Yeah.
Let's see. Standard deviation.
I did something very wrong on 13, so I'm not sure. Because I thought it was like p times 1 minus p over n and the square root of all of that.
Yeah.
So wouldn't that be 0.3 times 0.7 over 100 and then the square root of that?
No, because wouldn't it be? It'd be 0.3 times 0.3 or 0.7, 0.3 times 0.7.
That's what I said.
Oh, my bad.
Yeah,
That sounds right. Let me
try it again.
plug it in real quick.
No, I apparently did it wrong. So it's 0.0045.
So
How did you enter that?
So you do 0.3
Mm-hmm.
times 0.7 divided by 100,
Oh.
and then you take the square root of that. 0.045.
Yep. 1046,
what
right?
is,
Yeah,
what is
0.04
n supposed to be?
0.046. N is 100. It's the number of people.
45.
So it's B 0.046. Oh wait, so I guess do they want it?
Yeah. What?
Oh, they're trying to be tricky when they did 0.458.
Yeah, it's
Yeah.
0.0458.
Yeah, so it's 0.046.
258.
Yeah, so B. All right, so now we got to find the z-score, and that is value minus the mean over the standard deviation.
So P has.
So 0.3 minus 0.25, or sorry, 0.25 minus 0.3. Find that by 0.0458. So negative
That's
1.09 in the normal probability applet.
Oh. So
negative 1.092. Now, for this one, will we shade just the middle? Or what would we shade? Oh, so less than 0.25.
Less than.
So 0.137.
Yup.
So 138 is the.
C.
Yep.
Fuck.
I gotta find those Excel documents again.
Yeah, I'm trying to check through and see what the right one is. So I'm going to try this in the 2-sample z-test for proportions. So let's see. 1563. 61.
Which one are you putting it in again?
The 2 proportion test.
Okay.
But would this be? This would be a not equal, or so. Are we trying to find? What is going on? Something's jacked up with my. I think it's not working.
Oh, shoot.
I'm gonna try re-downloading those spreadsheets because that one was not working for me.
Okay.
Hey, I gotta bounce. So, I have 28 on it. I'll let you guys know real quick before I leave which ones we got wrong or right.
Okay.
You guys are money. We got them all right.
We did?
Sweet.
Awesome, dude.
Yeah. 15 is A, 16 is A, 17 is A. I could tell you guys all the answers if you would like.
Nah, we'll figure it out.
Yeah. But
So did you just submit it like early without finishing the rest of them?
yeah. Because I'm not gonna be able to come back to it tonight.
Okay.
But all right, guys. Well, good luck on the test.
All right. Thanks, you too, man.
Yeah. Have a good one.
Yep.
Bye.
So what am I wanting to put into these?
So N1 is the total number. So if you're in the 2-sample z-test for proportions,
Yeah.
you would put 1563 as N1.
Okay, that's what I thought.
And then, let's see.
You put how many are dizzy? Because I was thinking N1 would be how many is in one group and how many is in the other group.
That's true. So N1 is 1563, 579 is N2. And so the number of people that were dizzy in the first group and the experimental group was 61. And then it's 15 is X2. There we go. So
0.003 and 0.029.
that's what I got.
But I'm thinking that we're going to have to change these decimal points.
I think it's A.
Okay.
Negative 0.003 and 0.029. That's the right one.
Nice.
Hey, sorry, my internet cut out right there for some reason.
Okay,
You're good.
15 is A.
So I got, negative 0.003 and then 0.029.
Yep. Yes,
Okay.
that's A.
You
for
had your
15.
What's
I had it set to P1 is not equal to P2.
Okay, I guess they don't change for any
Oh,
of
did it
them.
not? Okay.
I think only the p-value changes.
Yep.
Yeah, so I think it's A.
For 15.
For 16. Well, yeah. Yeah, so for 15, A, and for 16, I think it's A.
Yeah, I think so too.
That sucks that Brock had to leave and not finish
Yeah.
the quiz.
No.
Test statistic is 1.458, so A.
Sweet.
4.5. Yep.
P-value 0.145, so D.
And that's with it not equal to, yeah.
Mm-hmm.
That's what I got.
Is there sufficient evidence? All right, so
No, we failed to reject the null hypothesis, right?
Correct. Or no, wait, failed to. Yeah, no, I failed to reject the null hypothesis. So the last one.
Okay.
Wait, is that right?
Yeah,
Isn't
I think so.
Oh, yeah, because 0.145 is bigger than 0.05.
Yeah.
That gets me every time, too.
It does too because I'm like, it's 1. It's less than 5.
I was thinking the same thing. I was like, hold on.
All right, so this next one is using chi-squared.
Yeah.
Great.
1, 2, 3. Um,
You just plug it in how it shows it, right?
Exactly. Yep.
yeah, I don't think you have to transpose it.
The only thing is, have you guys already changed your p-value and test statistic to be 3 decimal places?
I did, but every time, because when I exit out, I don't save my changes.
Oh, yeah, and
So,
I saved my changes, so I just remember. I think it was on this one that we
yeah,
got
it
some
was
things
this
wrong
one.
because we didn't change it. So
Because it tricked us.
because it tricked us. So I have the test statistic as being 6.579.
Yep.
That's what I have.
Okay. The p-value point
0866.
0.087.
087. Yep.
Let's see.
Tricky.
It is tricky. Test statistic is 0.05. So we
No.
fail to reject the null hypothesis because the p-value is greater than 0.05.
Correct.
So
So
D.
D.
No, p-value is greater than.
We fail to reject it.
We have
So is it insufficient? Oh,
okay. So with chi-squared, the way you do these tests, let me see if I can find it real quick because they make the wording really confusing.
Yeah.
So the null hypothesis is that the first and second variable are independent, and the alternative hypothesis is that they are not independent. So we failed to reject the null hypothesis, so the samples are dependent.
Okay.
So we have, or I mean, are.
They have to be independent because that's all that the answers have.
They have to be independent. So we have sufficient evidence to say that being an evening person is not independent, which means it's dependent.
Okay.
So we do have sufficient evidence, or we have insufficient?
We have sufficient evidence
I
because
feel like that's a double negative.
it is. It is. It really is. So the first variable and the second variable are independent, is the null hypothesis. We
Okay.
failed to reject the null hypothesis, so we have sufficient evidence to say that they are not dependent.
Not independent.
They are independent.
What? Okay, so which one is it?
I know, that's what I'm just. All right, so.
So it's either
Okay, so
A or B.
we're saying that they are independent.
Okay.
So we have sufficient evidence to say that being a morning or evening person is independent of age. So B.
Okay.
Yeah, those ones are always super confusing because there's like so many double negatives.
yeah, and I feel on all the other ones, like it's usually you have insufficient evidence, right?
Yeah, because you failed to reject it because you had.
Yeah, you have insufficient evidence. So
Mhm.
I think that's what gets me.
Oh man, we're only halfway there.
I know.
It's already been like 45 minutes.
Yeah.
Oh, jeez. Okay, so this one, we're looking for a proportion. think it's a one proportion test. So X is 50, N is 200, 95% confidence level, and we want those who outperformed the Dow Jones, so we want a greater than test. So I got 0.190 and 0.310.
So what's the null hypothesis?
Oh crap, I didn't change that.
That's what I have, but mine's 0.7.
That's what mine
I think
says.
we need to change it.
Yeah, I think you're right. 20%, 0.20.
Okay, yeah. So 0.20.
What was X and
And-
N again?
X is 50, N is 20. That didn't change the confidence interval, but it did change everything else. So
Yeah.
0.190 and 0.310, so C.
That's what I got.
Good call, Mike, on changing the null hypothesis.
Wait, which one is it?
Are you on the one proportion test?
Yeah, I think so. So
Yeah.
X is 50 and N is 20?
200.
Or 20.
200. Okay.
Confidence level is 0.95. Null hypothesis is 0.20. Type of test greater than.
Okay.
So C is 24.
Okay.
Suppose you've been charged. I'm trying to remember this part. So this would be from. Would it be? Is this like the point estimator where you have X over N?
I have no clue.
X over N.
What
I think
sample size would be needed to construct a margin of error of 2%? I'm not even seeing that in. Oh, here we go. It's lesson 17 recap.
what does it say?
So we need to do.
Prior
Okay, we can determine the sample size we need to obtain a desired margin of error using the formula n equals z over the margin of error squared.
Okay.
And that's times p times 1 minus p.
So it says if there's no prior estimate of
The formula
available.
z over 2m squared. So do we have...
Does that Z asterisk mean something different though?
No. That's just for this.
So
Alright,
we
so
have the margin of error. Let's
it does not give us the margin of error, no. So I think it's z over 2 times the margin of error squared. Z is 1.768 divided by 2 times 0.02.
I think so.
It is 0.02
Where?
times 2, 0.04.
Yes.
And then
So for the
squared, so 1954? Is that in there?
no.
No.
We are wrong. Oh, it's 0.2. Use the prior estimate of p equals 0.2.
Oh, okay.
So we need to do.
More sense.
So we need to do p times 1 minus p. So 0.2 times 0.8, 0.16. And then we got to do z over m. So, oops, 1.768 divided by 0.02 squared. And then times that by 0.16. 1251? Oh my gosh.
No.
The F David
Well,
Blaine.
okay. Let's see.
So what's the equation again?
What I was looking at,
Let me pull up Wolfram Alpha. Maybe we're doing PEMDAS wrong. So let's see. Z is
maybe it's just, let me try.
what is M?
M is the margin of error, and that's 0.02, right?
Oh, it'd be 0.002 though, right? Or wait, no.
If it's
Well,
2%, it would be 0.02.
Yeah. Okay, yeah.
Yeah, I keep getting 1250. I think our margin of error might be wrong though.
So it says a margin of error with 95% confidence. Oh, maybe.
Maybe not. Let's see.
Try this.
This doesn't seem right. I think it might actually be the Z asterisk is something different. It's the point estimator of Z.
Oh, you know what? Does that mean we need to get the proportion? So we need to do x over n. Let me try that. So we do 50 divided by 200 is 0.25. Put that in the normal probability applet. Oh my. It just went crazy. There we go.
Ugh. Yeah,
And then we want to know. Alright, I'm going to try 1.15 as the Z.
okay. You could always work backwards too, so just do. So that number is, what did you get?
1.15.
So I worked backwards to
Mhm.
find the Z, and it's 0.17888. I don't know if that'll make a difference.
I don't know, I'm trying it with the 1.15 first. And then yeah, I don't think it was that because that gave me 529. All right, so what was your points?
I'm doing it right now. Came up with. That's not right. What did I do different? I wound up with 0.1279. So I don't think I did it right.
For the Z, you mean?
No, just for the answer.
Oh, yeah. Wow, I'm totally lost on this.
Yeah, I'm lost too.
Down to
What question is this again?
So wait, what did you get again? What was your last answer that you got?
529 or something like that. Hmm.
hold on. Do we even need to figure it out? Because doesn't it just need to be larger than 30?
Has to be greater than 10.
Oh,
Um,
Yeah, and it asks for a specific number,
yeah.
so I don't think that's
2%.
the answer.
Yeah. All right, so the margin of error is Z times the square root of P times 1 minus P over N. If we solve for N, we get N equals Z over M squared times P times 1 minus P. If we have a prior estimate for P, we can plug this value into the equation to compute the sample size.
So this is irrelevant, but I found a pretty cool chart that tells you which test to use for a few of them.
Awesome.
Post that in the chat.
Oh, we're so dumb. It's 95% confidence level, 1.95 or 1.96.
What?
Z for 95% is 1.96.
Oh, dang it.
Okay, so we want to do 1.96 divided by 0.02 squared times 0.16. 1537.
Oh my goodness.
Yep, right there.
Spent about 25 minutes on that problem.
You know what, though? We will never forget that.
I hope not.
So lame. Okay. You want to see evidence? It's one of the top 10. I think it would be E. P equals 0.2 and P is greater than 0.2. Because you want to see if one of them performs better than the other investment managers.
I think that is correct.
I'm good with that.
What requirements must be met? A.
Greater than or equal to 10.
Mm-hmm.
Okay.
Test statistic is 1.768, so B. P-value 0.039, so A. We reject the null hypothesis because it's lower than the test statistic.
So that's A then.
Yep. And
Oh my.
Whoa.
This one's like a straight up essay.
we saw this one before.
Blue scores.
Oh, so we gotta download a new
Yeah.
spreadsheet.
I like these ones. They're usually pretty quick and easy.
Yeah, so is this a
It's a
one sample t-test?
Gotta be. I mean,
you only get one set of data.
Alright, so is the confidence level I guess we assume confidence level is 0.9. Oh, it's 9.5, he says. What's the null hypothesis?
wait, which test are we doing?
A one sample t-test, I think.
Is that in descriptive?
Quantitative.
Yeah. Oh no. So it's in quantitative.
Quantitative inferential procedures.
Right there. Got it.
Okay.
So one sample t-test.
Do we need to put in the mean, standard deviation, and or any of that?
We don't, but we do need to change the null hypothesis.
Okay.
He wants to use the data to see if his mean differs from the mean of another leading translation software, which is 0.295. So this null hypothesis is 0.295. Oh, there we go.
Greater than?
Not equal to, I think, right? Or
What's he say? Oh, yep. Because he wants to
differs.
know if it differs.
Yep.
Okay.
Okay, so the lower bound I have 2.82 or 0.282. 293.
Yeah, 0.282 and 293.
99.
What? You got 99?
For the degrees of freedom.
That's what I got.
Oh yeah. Yep. Yep. I was looking at the wrong thing.
And I'm going to put in 0.000 just in case.
For which one?
For degree 99.000.
Oh.
Because that's exactly what it has in here. Test statistic negative 2.803.
I thought you were talking about you're gonna put in 000 for the test statistic.
Oh.
I was like, well, what did I do wrong? Oh no.
0.006 for p-value.
Yes.
Yep.
.006.
So based on that, I would say
We have.
They are different. Right?
yes.
We have
Yep,
sufficient evidence that they are.
that they are different. So A.
So it's
Yeah.
oh my, some more.
We love these.
Sure. Oh boy. Oh, we did this one before, didn't we?
Yeah, so this is paired sample.
So many Excel documents. I do have to say though, with this new laptop, I put Office 2016 on it, and it's running much smoother than.
I need to get 2016. I only have 2013.
The school has it for free.
I know. I'll get it.
Is there a big difference between them? The both of them?
There's a few like layout differences, but for the most part, like these Excel sheets are running a lot smoother.
Yeah.
But that may also be that I've got a computer that's not got busted stuff all over it.
Okay, so I put in the variables. We want 95% confidence level.
Mm-hmm.
What's the null hypothesis?
Conducted significance of 0.05, right?
That's the level of significance, but what's the null hypothesis? We're trying to say what? Oh, I guess the null hypothesis would be 0, that they're equal.
Yeah.
Okay. And so the type of test, is that greater than?
Taller in the morning than in the evening. So,
I think it's greater than.
well, it depends which. Yeah.
Would it be greater than or just? Yeah. Yeah. So they're taller. So I think it would be greater than.
Yeah. The only thing is that gives me a crazy p-value.
Yeah, it does.
That's what I was asking about. That may be one of those trick questions where it's like 0.000. All
Well,
right, so
I think all of them are greater than and not equal to give crazy p-values, and then less than is just 1, and I don't think that's the answer.
yeah. Okay. So my lower bound is 13.963.
Whoa.
Is that what you guys have?
No.
What have I done differently? There's a whole lot of data in there. Okay. So I have confidence at 0.95, null hypothesis at 0, type of test greater than.
Yeah.
And I have
What's your means and stuff on your ends and
925.549, 897.787, and 27. Oh, the difference is 27.
41
for your N. Should be
for your
41.
N?
Oh, my N I have 89.
Yeah,
Whoa.
you added them both to the same.
Ooh.
That'll do it.
What? How did I do that?
Yeah, because for my confidence interval, I have 8.728.
Me too.
Yeah,
Yeah.
okay, that makes a whole lot more sense. I'm like, what the heck is going on here? Okay.
Then you got your upper bound is 10.455.
Yeah, so lower bound 8.728
Yep.
and 10.455.
Yep.
Hallelujah.
And test statistic is 22.446, right?
Yeah.
Degrees of freedom is 40.000. P-value is 0.000, right?
Yes, it is.
Yeah. I think I remember this one being that. Too.
iLearn hates us.
Yeah. Yep. 42. We reject the null hypothesis. So there's insufficient evidence to suggest that they're taller in the morning than in the evening.
No.
No, because we rejected the null, so B. All right, I'll submit.
That was a long test.
That was a really long test, especially since we spent like 25 minutes trying to figure out.
I have a feeling that the test is going to be brutal.
We got an A. Wait. So question 42 is C.
What?
Oh, the null hypothesis is that there was no difference, and the alternative hypothesis is the children. So that was.
Was that the only one that we got wrong?
Let me check. I think it might be. That. No, 23 is D.
You said 23?
Yeah, 23 is D. We have insufficient evidence to say that being a morning or evening person is not independent. Ah!
Holy cow.
And that's it. Everything else is right. But even with those two, still an A.
Well, yeah, because 42 questions.
Yeah.
Now, if I can just
Holy shnikes.
test, I'll be golden.
All right, and this one, I don't think we have to post this video, right?
I don't know.
Let me check real quick. I don't think that we do.
Well, either way, if we do, we were within 2 hours of.
Yeah, no, we don't have to. There's no like group collaboration on this one, so we don't have to post it.
Good.
So just the test that's due tomorrow. Hopefully, Mike, he'll reset it for you.
Oh man, if not,
He has to. Like.
I know. I don't see why he wouldn't. I mean, unless he thinks I'm like opened it and was like looking at all the answers. But
Well, and I've got this video. Like, we're not posting this video, but I'll save it and he can watch it and see that you just closed out of it and emailed him. So if he needs that evidence, then I've got it.
Perfect.
Awesome.
All right.
Well, good luck, boys.
Good luck.
All right. Good night, guys.
Hey, Lauren, you gonna be playing? No, he's already gone. Later, man.